A robot is, at bottom, an automated system with a body. Everything from the last two lessons still applies. Sensors, a microprocessor, actuators, a loop that repeats, and robotics adds physical form and movement. Three characteristics define one: a mechanical structure, a physical body with parts that move, arms, joints, wheels, grippers. Sensory input, sensors letting it detect its surroundings so that it responds to the world rather than moving blindly. And programmability, it contains a microprocessor and follows stored instructions, which can be changed. Test those against ordinary machines and the boundary becomes clear. A washing machine has a structure, sensors, and a program, but nothing about it moves through or manipulates the world, so it is usually called an automated system rather than a robot. A remote-controlled car has a body and moves, but a person is deciding everything, so it fails programmability. A robot vacuum has all three. It moves, it senses obstacles and drops, and it follows a program it can be given. It is the combination that matters, not any one feature. The roles the syllabus wants, and each one has a reason attached that is really what is being marked: industry and manufacturing, welding, painting, and assembling on production lines. The reason is consistency and endurance, identical work to the same tolerance continuously with no fatigue. Medicine, assisting in surgery with very small incisions, where the reason is steadiness and precision beyond a human hand, and faster patient recovery because the incisions are smaller. Note that these robots assist rather than replace. A surgeon is controlling them. Dangerous environments, bomb disposal, underwater work, space exploration, nuclear decommissioning. The reason is simply that no human life is risked, and it is worth appreciating how completely that changes the calculation. A robot destroyed on Mars is an expensive loss, not a fatality. And domestic, vacuum cleaners and lawnmowers, where the reason is relieving people of repetitive chores. Two more roles the syllabus names specifically. Drones, unmanned aerial vehicles, are flying robots, either remotely piloted or following a programmed route autonomously. Aerial photography and surveying, delivering medical supplies where roads cannot reach, inspecting bridges, wind turbines, and power lines without erecting scaffolding, search and rescue, and monitoring crops. The benefit in almost every case is reaching somewhere a person cannot easily or safely go, and often doing in an hour what would otherwise take a team a week. And agriculture, robots that plant, monitor, and harvest, drones surveying fields to identify areas needing water or treatment, autonomous tractors guided by GPS. The benefit there is precision. Treating individual plants rather than whole fields reduces the chemicals and water used, as well as the labor, so the environmental argument and the economic argument point the same way, which is unusual and worth mentioning if a question invites discussion. Now, the advantages and disadvantages, and the useful observation is that they come in pairs from the same root. Robots work in conditions unsuitable for humans and cost a great deal to buy and install. They perform repetitive tasks with complete consistency and no fatigue, and they replace human workers, which causes unemployment in exactly the roles that were repetitive. They are more productive, needing no breaks or holidays, and they require specialist skills to program and maintain, so the jobs that remain need different training from the jobs that went. Look at what is happening there. Each advantage and its matching disadvantage are the same property described from two positions, an employer's and a worker's. Consistency is valuable precisely because it removes the variability a person introduces, which is another way of saying it removes the person. That is why questions on robotics so often ask for discussion rather than a list. The trade-off is genuine, and an answer that only sees one side has not understood it. It is also worth knowing what robots are bad at, because it sharpens the choice in a scenario. They are poor at tasks needing judgment about unfamiliar situations. A robot on a production line is superb until something happens that was not anticipated, and then it either stops or does the wrong thing confidently. They are poor at fine manipulation of soft irregular objects, which is why fruit picking took so much longer to automate than car welding. Every strawberry is a different shape and bruises. They cannot easily be repurposed. Changing what a robot does may mean re-engineering as well as reprogramming, and they need a controlled environment. Factories are laid out for robots, not the other way round. So, if a scenario describes an unpredictable environment, delicate or varied objects, or work needing judgment, that is where a human still wins. And saying so is a stronger answer than assuming automation is always better. Let me finish with the question type that actually appears, because it is rarely just describe a robot. You are given a workplace and asked whether robots should be introduced and expected to argue it. Take a car factory fitting windscreens. The task is repetitive, identical every time. The parts are heavy, the environment is controlled, and the volume is enormous. Every one of those points to robots, and the justification writes itself. Consistency, no fatigue, safe lifting, and the high initial cost spread across a very large number of cars. Now change the setting and watch the answer move. A restaurant kitchen. The task varies constantly. Ingredients differ in size and firmness. Orders change mid-service. The space is cramped and was designed for people, and the volume is modest. Almost everything now points the other way. Unpredictable work, delicate, irregular objects, an uncontrolled environment, and a cost that cannot be spread. And notice a third possibility that stronger answers reach for. It need not be all or nothing. A kitchen might automate one narrow task, such as a machine that portions rice consistently, while people do everything else. That is how automation usually arrives in reality, not replacing a job, but removing the most repetitive part of it. If a question invites discussion rather than a decision, saying so is worth more than picking a side. 4 things to take into the exam. First, define a robot by all 3 characteristics together: mechanical structure, sensors, and programmability via a microprocessor, because any one alone describes something that is not a robot. Second, when naming a role, attach the reason. Not just that robots are used in dangerous environments, but that no human life is at risk. The reason is usually the mark. Third, use the correct term for movement. Actuators convert the microprocessor's electrical signals into physical motion, and naming the actuator is what shows you know how the movement happens. And fourth, when discussing impact, give both sides and connect them. The same consistency that makes a robot valuable to an employer is what displaces the worker whose job was to be consistent.